So today we are going to understand distributed caching system, how to implement it. So to understand it, first we have to understand what does caching means. Caching is nothing but the fastest memory which stores small amount of data which is frequently used or frequently demanded by the web servers or web applications. So here user can be web application or can be mobile apps which request the data from the server, and then server demands that data from the or fetch the data from the database. So it is a lengthy process, and for every request performing the same number of operations is kind of heavy task, or it consumes time. So to reduce the time consumption, we the caching was introduced. What does caching does is, so web application demands or requests data from the server, and the cache memory is placed between the server and the database. So when web applications request the data, the server searches that data in the cache first. If the data is present in the cache, then it returns the data from the cache. Otherwise the data is fetched from the cache memory fetches data from the database and stores in the cache memory, and then cache memory returns it to the server. So cache memory indirectly reduces the time for fetching the data from the database again and again, because database contains heavy amount of data and cache contains less amount of the data. So that's why cache memory is used. So here the problem come that every time when a data is getting stored in the cache memory, the cache memory is also getting fulfilled, or its storage getting reduced. So every time removing data, use data from the cache memory is uh, manually kind of heavy task. So when the data is fetched from the database to the cache, a time constant is also given, like 3600 second, that after 3600 second the data will be removed from the cache memory. But what if every time the new data, uh, the request from the user comes for the new data, and then the cache memory is also filled, because every time new data is demanded, and the data and the cache memory retrieves that data from the database, then that time multiple navigation policies is used to remove the data from the cache memory, like LRU, MRU, LIFO, FIFO, etc. So here we can see that if here the question comes that if one cache memory of one cache server is working properly, then why we require the distributed caching system? So the answer can be simple, that if multiple request is raised from the server and the cache becomes overloaded, then it can fail. And if it fails, then the situation comes normal. The situation comes same as without the cache memory, and that every time the request has to be fulfilled by the database. So in order to use rather than one cache memory, we use a pool of cache servers. Here it is a pool of cache servers, means there are multiple cache servers, like uh, cache server 1, cache server 2, cache server 3, cache server 4, cache server 5. And now here the question comes that which when a request is made by the client, then the request made by the client is fulfilled by which server, or if the server fetches the data from the database, then the information is stored in which server. So it's simple solution. So it has many techniques. um, like first one is hashing. In this, suppose we have five server, s1, s2, s3, s4, s5. In hashing we have to first find out our parameter and then we perform modulus operation by any given or number chosen by ourselves, and the remainder, if suppose if the remainder comes 1, then that data will be stored in s1, and comes 2, then the data is stored in server number 2. So in hashing technique we have to use our parameter and the number through which we are going to perform modulus operation very wisely. But it has a drawback that suppose we have to add another server, let's say s6, then we have to change the number, and the data in every server changes. So need to changes. So it is very difficult to scale um, scale in this technique, in simple hashing technique. So to overcome this problem, we have consistent hashing. It is nothing but in this, it is a ring like structure in which servers are allocated on the border like s1, s2, s3, s4, s5, s6. Here in consistent hashing, the server is selected on the base on the in the anti-clockwise, by moving anti-clockwise direction, and if the first server is free or having space, then we can allocate that server to the for storing the data. It is the another technique, and it is easily scalable. Suppose we have to add another server, let's say s7, and then still the finding of allocation starts from the s1 and goes in a clockwise direction, and s7 is occupied in the last. The third technique comes, which is nothing but the shading technique. In this, the main main data of the kernel is divided into the two parts or multiple parts based on the particular parameter. Let's say we have the uh, em- employee data and we want to distribute that data. Then let us uh, assume the parameter as alphabets. So from let's say this shade 1, it contains the employee whose name starts from A to G, and the shade 2 will contain the employee's name from H to K, and this. So we can simply divide the data into 4 shards, but here is also a problem that what what if suppose a shard 1 is not accessed frequently, not exist in equivalent time as compared to the others, and let's say that shard 3 exist frequently again and again and again. So this also becomes a aspect problematic aspect. So we have to choose our parameters of distribution the data very wisely. And the fourth technique comes as master and slave technique, in which we create a duplicacy of the data. Let's say this is the master data, and here its replicants R1, R2, R3. And the reason behind this technique was to reason behind this technique was the simple fact that the normal website, the uh, number of reads is more than number of writes. So if we have to perform any write operation, we perform it in the master uh, master data, and if we perform any read operation, then we can simply read it from the slaves. The slaves are nothing but the proper copy of the uh, master data. But in master data, what we need uh, what the needs which needs to remember, like first we have to maintain data consistency, because suppose in the data consistency, suppose if the there is any write operation in the master data, then we have to update the slave as well, otherwise the updated value will not be read by the user. So in order to perform proper information, we have to uh, properly update our slaves too. So we have discussed multiple techniques uh, which can be helpful in various use cases. So like um, if we want fast read and less fault fault tolerance, then the best use technique can be replication, that is master and slave technique. And if we want to design a scalable application, then we can simply use sharding technique. It simply divides the data into two parts, like main data into two parts, half one, half two, or we can say data can be divided into multiple parts. And the best technique, which is mainly used for the large scale applications, that is hybrid techniques. Hybrid techniques is nothing but the combination of two or more techniques. uh, Hybrid techniques helps us to overcome all the cons of all the techniques of the distributed caching system. um, Finally we can conclude that if the application is heavy, or the application have many users, then we have to use multiple distributed caching system. And because of distributed caching system, the data retrieval is fast, and failure of the one cache server will not result in the failure of the application, and the others can smoothly retrieve the data or update the data, and can perform multiple operations as per their requirements.